Okay, folks, welcome back. It's been a little while since last time I did one of these indexing deep dives. I took some time off over the holidays, and then, when January rolled around, I could no longer record videos at 7 a.m. because, my wife and I decided to rejig, getting the kids ready for school, and I'm responsible for taking my younger daughter to school on, every day. So, 7 a.m. no longer works. So I've decided to start recording these videos during the day. I'm not doing them on Meetup. Instead, I'll just record the videos, as myself. Oh, I'm realizing I'm on the wrong branch. Yeah. So it'll just be me recording the videos and sticking them up on YouTube. So this gives me a bit more flexibility. Okay, so let's continue where we left off last time. So we're still on our journey through indexing. I left things on a bit of a cliffhanger last time because I said like, oh, we're very close to the point where we actually hand off the document to Lucene. But that's here. We were in IndexShard in its index method, where we have an engine, where the engine is the abstraction, that kind of wraps an index basically for reading and writing. Engine also has a method to get the searcher manager. But at this point we have the engine level index operation, which has information about, the primary term, sequence number, so some of this stuff is related to transaction logging. And let's go to where the index shard hands off this index operation to the engine. Now, engine itself is an abstract base class, or it defines some common logic, not a lot. But there are some, there's some common stuff across all engines. But let's go into the actual engine implementations. So the one that I'm going to dive into is called internal engine. That's kind of the default. Actually, since we last recorded, a new engine, the ingestion engine, has been added. This adds support for pull-based indexing in OpenSearch. We're very excited about that. And, thank you very much to Yupeng from Uber for contributing that. That's awesome. But for now, we're not going to get into the pull-based one, because actually the ingestion engine, if I recall correctly, so it does still call index. I was curious about that because, with pull-based indexing, you actually can't do it through these indexing APIs. It's that the engine itself pulls from a stream like Kafka or Kinesis. But let's go into the internal engine implementation, because that's sort of what's used by default. Okay, so we have the indexing operation. We acquire, the read lock to make sure that nobody else is trying to read, or sorry, make sure that there's, I guess, not another write, because the read lock, this should be a reentrant read-write lock under the hood. So multiple things can read, but we want to guarantee that reads and writes don't happen concurrently. So anyway, let's go through. I see this index throttle variable is unused. That suggests some dead code. We should probably clean this up. Okay, the fact that releasable lock is unused is fine, because we're just relying on the try with resources behavior to guarantee that when we leave this block, the releasable lock will get. Oh yeah, that's why index. Oh yes, of course. Same thing with index throttle. Sorry. That again, we're just relying on the try with resources. So yes. Okay, so that's fine. That's not dead code. Though I guess actually on OpenSearch main, we can. Okay, so they're suggesting that we rename to ignored one. I believe with the newer versions of Java, you can do a try with resources without allocating a variable. But okay, let's continue through. So, okay, we come down here. We're this early result on pre-flight error. I'm not so this seems to be that, yeah, we've kind of determined that, there's a problem with this, that the plan that we've determined. Oh yeah, so we do this indexing strategy. We compute the indexing strategy. So yeah, so what this is doing, the key thing with this plan is kind of like, hey, is this, well, yeah, we determine, are we going to index this into Lucene, or I guess, are we just going to add it to the translog? The use Lucene update document and the version for indexing. So Lucene has an update document API, which you can use to add new documents. But what it does is it first does a check to see if, to find an existing version so that it'll overwrite it. Because an update ends up being a delete and an add. And so, yeah, with this indexing strategy, we can kind of figure out, like, okay, can we, so this optimized append only, if we can determine that, this is an append only case, that we can guarantee that we've never seen this document before, then yeah, we don't have to use the Lucene update doc because we know that we're not overwriting anything. We're simply inserting. And it does save some effort, a decent amount of effort actually. That if you can guarantee that it's append only, your throughput can be, a fair bit faster. So yeah, so that's kind of where the indexing strategy fits in. So now, okay, so it looks like if the origin of the operation is the primary, and we clone the index object, not quite sure why we're doing this. Yeah, otherwise we're marking the sequence number as seen. With the origin being primary, I think this may be code that executes on the replica. And so it's sort of saying like, oh, okay, well, yeah, we can just, oh yeah, actually, no, the fact that it's generate sequence number for operational primary. Okay, so this must be that we are executing the operation on a primary shard, and so therefore we have to generate the sequence number. Okay, yeah, and so these sequence numbers, if I recall correctly, are just auto-incrementing counters. I believe it's basically, yeah, do generate sequence number. Yeah, so we have the local checkpoint tracker. It has this generate sequence number, which, if I recall correctly, yeah, it's just an atomic long, and we do get an increment to get the next unused number. And essentially, all we're trying to do is, guarantee that sequence numbers are generally increasing. Obviously, you can have multiple threads running. Things may be indexed slightly out of order, but that they're generally increasing. There is in that local checkpoint counter some funny logic to, kind of break sequence numbers into blocks. And, sort of once every sequence number in a block has been seen and persisted, then we're like, okay, yeah, this block is good. And that way, with the transaction log replays, you kind of know like which blocks do you need to consider. Like once a block is fully durable, then yeah, it's safe to throw it out. But yeah, so that's kind of sequence numbering. Yeah, we come down here, and yeah, so we have this, if the plan is either to index into Lucene or add a stale operation to Lucene. Yeah, I'm not actually familiar with the add stale operation to Lucene. Maybe we can get into that when we get into the index into Lucene. We might be able to see what that actually does. But yeah, here's kind of the, we're almost there. We're almost there to, you know doing the actual Lucene indexing. So we've got this index object. Within the index object, we have this thing called the parsed doc. So this parsed doc is built up by the field mappers. The field mappers are responsible for taking OpenSearch field objects, like OpenSearch field types, and converting them into the underlying Lucene fields. The Lucene fields are much more basic, kind of less explicitly schema aware. Like Lucene itself is mostly schemaless. There are concepts where, yeah, there's not really a schema, but a field, when it gets added, it'll have some attributes, but mostly those attributes are related to, like, as I index this document right now, as I index this field right now, what data structures am I going to create? And you can sort of change these dynamically. You can say, like, oh, I'm going to add a field name named foo, and in this document for field name foo, I want to generate doc values for it. I want to index terms. But then you can have another document where you say, well, here for field name foo, I'm just going to index terms, but I don't want doc values for it. And that's fine. Essentially, it's like you're adding an empty set of doc values. Lucene will kind of figure that out. Where in OpenSearch, there is a much more rigid schema in the form of the index mapping. And so this parse doc is kind of the result of having gone through the index mappings. Sorry, I'm just going to close an overlapping window. Going through the index mappings and producing the resulting Lucene field, because if we look at a parsed document, we do have, okay, so this is a Lucene level field called version, and it has a list of documents. Now, the reason why it's a list of documents is because you can have nested documents. If there's no nesting, then this list will have size 1. If you do have nested fields, the parent document will be the one with index 0, and then the children will be the subsequent documents. And this is important because in order for the parent document and the nested documents to be searchable, the way that Lucene's block joins work, they must be indexed contiguously, and they must stay together within the Lucene index, because a lot of the block join logic kind of works on the assumption that you have the index, the doc IDs for parent documents, and you could tell that a child is associated with a parent document based on its position between two parents. So that's parse documents. At some point, I would love to get into the construction of the parse documents and how field mappers relate to that. But that'll keep us even further away from the actual process of indexing. So we're almost there. So you can see that the engine holds a reference to a Lucene IndexWriter. So this is, has an IndexWriter field. So let's go into the update docs, because that one feels like the most general one. So in this case, it's saying we can't guarantee that this document doesn't exist. Maybe we have to do an update. So all that's doing. So we have the underlying documents under, well, this is a parsed context docs. Okay. So we have the parsed doc, which has doc, but we also have the index operation, which has the parse context docs. So I guess because we're calling into IndexWriter, these parse context documents must also be Lucene documents, I guess. Oh yeah, or at least they look enough like Yes, Lucene documents at write time. Yeah, we look at Lucene's document class. Sorry, I'm just going to jump into this one as a slight diversion. You know what? I had it from parse document. Oh no, they're the same parse context documents. Okay, yeah. The essential thing is that when you index a document, really all that Lucene needs the document to be is an iterable of indexable field, right? So I don't have the Lucene 10 source code downloaded, but a document is an iterable of indexable field, right? A document is just, a list of fields, essentially. So in this case, because we have potentially a block of documents, here's where we do the the block join sort of behavior. Oh, sorry. Here's where we do the block join behavior, because it's update documents plural, where we send a block of documents. There's a very slight optimization where it's like, oh yeah, no, if it's not a block, we can, update the single document. These soft updates end up doing, a so-called soft delete of the actual document. So it doesn't actually mark it as deleted. It kind of marks as deleted with, with a tag, if I recall correctly. Yeah, so it ends up having some internal, yeah. So it does this doc values update. Yeah, so it makes use of Lucene's updatable doc values to kind of update the state to say, oh, this thing's deleted. It doesn't put it into Lucene's live docs or, strike it from Lucene's live docs yet. But that ends up happening later once the soft deletes are applied. Yeah, so this is update docs. We can also look at add docs, which is very similar, where, again, it's a little bit simpler because we're just adding. So, we don't need the parent term. Yeah, that was a thing in the update doc. So yeah, we have the UID. Yeah, so this is the unique identifier for the parent doc, which we get. Okay, so yeah, it's the UID associated with the index operation. I believe this is actually related to the actual document ID. Where do we populate the UID? This may be a bit too much of a rabbit hole. Yeah, I'm not sure. Yeah, I would have to trace through it. The UID, I believe, is related to the actual document's ID, though. Oh, there may be, yeah, there may be something beyond that. Does it need a shard identifier? Probably not. But yeah, anyway, so when you're adding, because you're guaranteed that you're not, you know, soft deleting an existing doc, you just either add a block of documents or add a single document. And for statistics purposes, we have this counter, that we're keeping track of, how many appends did we do? Similarly, with the update docs, yeah, we keep track of how many updates have we done. I'm a little bit curious about this add stale docs. I'm not familiar with this, so I'm just kind of curious. Oh, interesting. Oh, ha ha ha. Oh, that's kind of cool. So this is, I believe, related to guaranteeing, sort of consistency around knowing that if you look at a particular cut, yeah. So if things get out, get processed out of order. Sorry. Yeah, this is, let's say I know that there's another version of this document coming, that may be before or after this, or, probably definitely after this, then yeah, I may want to put it in kind of pre-soft deleted, I guess. Yeah, so that seems to be what add stale docs is doing, is it's adding the documents, but kind of marking them already as soft deleted. That's kind of neat. I wasn't aware of that. But yeah, I guess it kind of makes sense when you can have out of order processing. Yeah, so that is the key piece where the actual IndexWriter stuff happens. Since we still have plenty of time, let's go, you know, back through and sort of see like, hey, how do we go through the response path? So, of course, this index into Lucene operation, it returns this index result. So, we can look at the plan to see if, we created a new doc, which basically, when we constructed that plan, we determined, oh, is this going to be an update? I guess technically, even if, huh, no, actually, I guess if a previous document, this use Lucene update document and the current not found or deleted should be mutually exclusive, I think. Because, yeah, if you have a soft deleted document, you probably still don't want to do the update docs, I think. I believe if the previous version has been soft deleted, I think you can do an add docs, but I'm not positive. I would need to look into that. So yeah, we return the index result with the information about whether we created a fresh document, either because the previous one was deleted or because we're appending. Yeah, I think we saw before the index result with a required mapping update where we didn't actually create something. We instead took a trip out to the cluster manager to update the index mapping, waited for that to complete, and then tried again. So we've seen that before as a possible indexing result. But in this case, it's the index result where it's like, no, we actually did the thing. We actually indexed into Lucene. And so let's keep going back. Yeah, so here we were back in the engine.index method. So we've got the index result of indexing into Lucene. So it looks like, yeah, we need to notify the translog, I guess, that we've indexed the thing. So yeah, there's this internal version map. So this live version map, unless I'm mistaken, I believe this is the thing that when we get the indexing strategy, this is the thing that lets us determine if we can do an append versus, yeah, I think it's an append versus stale versus update. So this version map, as I understand it, it's sort of for every UID. Yeah, it keeps track of this index version value, which is, you can kind of think of it as simply the index version, like the doc version, the internal document version. And yeah, this is the thing where like the latest version always wins. Oh yeah, and actually this version for indexing, if I recall correctly, is either auto-generated or produced from an external version. So if you're doing external versioning, this version for index is provided by you, the user, but by default, if you don't specify external versioning, then you just rely on OpenSearch to auto increment document versions, and it's essentially, I believe, via this version map, kind of saying like, oh, hey, do I know this thing? Yeah, if not, then give it probably version 0. And then otherwise, if I have seen it before, whatever the latest version is, do that +1. And yeah, so yeah, the version map now needs to be updated because we indexed into Lucene and the result was success. So yeah, the version map needs to be updated to say, yep, no, here's where we are. Here's what's in the index. Now, yeah, we also keep track of like, oh, here's how long it actually took us. The index.start time was, did we initialize? Oh, nope. This is the last write nanos. Yeah, I guess the index start time was probably set when the index was created. This index object was created. Yeah, it was actually passed in as a constructor parameter. Yeah. Oh, no, sorry. This is where we're copying it. Yeah, and generating a sequence number for an operation on primary. So yeah, I don't know when the start time was actually initialized, but a while back. But yeah, in the result, we say, okay, here's how long it took between when the start time was set and now. And then finally, this freeze. Yeah. So there are all these setters, right? Where, yeah, basically this freeze is saying whether or not you can, set or call the setters, or if it's too late. And yeah, this is an instance of set once. So freeze.set can be called exactly once, because otherwise, yeah, that'll throw an illegal state exception. Or sorry, already set exception, which should probably extend, which extends illegal state exception, which makes sense. That you can't freeze something more than once, and once you've frozen it, then yeah, nobody else is allowed to modify it on the way out, which makes sense. That you wouldn't want some other part of the code to say like, oh, actually the took time was something else, because that could be misleading and very confusing. So where so we had the I've lost. Okay, so we're returning the index result. So who was it who called us? It was IndexShard who called us. So let's pop back up to IndexShard. So we've got, yep, the index result from calling engine.index. And then, so for anyone who's listening to indexing operations, I don't know what indexing operation listeners we have built in. Oh yeah, there's the indexing slow log. Yeah, that makes sense. The indexing memory controller. So this one, yeah, so it wants to kind of see, hey, how much memory are we using for indexing? And this relates to, kind of the circuit breaker behavior, the kind of back pressure behavior, where we can say, whoa, 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 whoa. I assume in well, we would want to listen for the pre-index, I would think. But yeah, we record the bytes in the post index, but I would assume that we would want to do a pre-check, yeah, as a way of determining that it's not safe. Well, okay, yeah, okay. So we can activate throttling. So this thing is responsible for activating and deactivating throttling. Where we say, whoa, 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 we're kind of getting overloaded here. The throttling isn't straight up, blocking indexing. It forces it down to one thread. So, which, yeah, ends up creating back pressure because, as long as that one thread, is handling the operations, then things are going to start queuing up behind it. And eventually that queue would fill up and we would start rejecting things, I guess. So, yeah. So that's one of the examples of a listener. So, yep, we let the listeners know that, yep, we have an index result. Yeah, and so we're done indexing. Let's pop back to who called IndexShard, dot index. Well, this was apply index operation, which, yeah, again, so this is the thing that prepared the the engine.index operation. I guess this is probably the thing where the start time, yeah. So this is where start time was set. So the took time, right, was the time between when we called prepare index and when the engine created the index result, set the took time, and froze it. Yeah, now who called apply index operation? Well, something within this. So we've got three candidates. Oh yeah, we were focused on applying the index operation on the primary, but there's also, yeah, the apply index operation on replica. It's interesting looking at the difference between the two of these. So when it lands on the replica, the primary is responsible for generating the sequence number. So this is where when we apply the index operation on our primary, we have an unassigned sequence number, but we also have to figure out the operation's primary term. But again, that's the sequence number and the primary term are propagated from the primary to replica. So we have both of these. On the primary, we have this IF sequence number. I don't know what these IF sequence number and IF primary term are. Well, let's get back to who called us. Yeah, what is that? So we were back in transport shard bulk action. So again, we're kind of popping back up the stack. This is where we were before. So it was in the index request. Yeah, I'm kind of curious about what this F sequence number and IF primary term are. Well, if set, only perform this indexing request if the document was last modification was assigned, or I guess if the this is, I think this is supposed to say if the document's last modification was assigned this sequence number. If the document's last modification was assigned a different sequence number, a version conflict engine exception will be thrown. So yeah, and same sort of deal with the IF primary term. Oh, you know what? I think this relates to the update API. So yeah, the idea is, yeah, I think we looked a little bit previously at the update API maybe, or at least I know I spent some time a while back looking at the update API. Yeah, so yeah, when you do an update document, essentially what happens is it says like, oh, okay, well, let's go get the existing document, apply some changes to it. We've now got a new add or update request, but we don't want to apply that if somebody else snuck in and updated the document in the meantime, right? Because it may be, yeah, we start an update, we've, gone and like fetched the existing version, merged the fields from the existing version with, like, especially if you have a scripted update, right? Where you say like, oh, I want to set some field value to that field value +1, but then somebody else has snuck in and just, applied an unconditional right to that document. Now your update wouldn't make sense. Okay, so that makes sense. That's where these would come from, is if the index request was created as a result of an update operation. Cool. Yeah, that makes sense. Okay, so yeah, we're back up here. So this was the execute bulk item request. We have an index result. Recall that we at some point got into the logic around the mapping update required. Yeah, I believe that was okay. So here's where we did the update processing. Yeah, the determination of mapping update required. Did we do that in the apply index operation? Yeah, I think that may have been, yeah, that was in the prepare index. Yeah, so that was when we prepared the operation. That's where we check the mapping and we say like, oh, hey, this document contains new fields that we didn't know, that we hadn't seen before, and so that's where we kind of short circuit return an index result. Cool, cool, cool. Yeah, I think we've already been through that, and so here's where the logic to, kind of do that call to do the mapping update. Yeah, so we call mapper service merge. Okay, so yeah, so this is just on the primary. Oh yeah, so this is the primary. Here we're doing the pre-flight mapping update. But then it's down here where we call the mapping updater. This is the one that goes and does the call out to the cluster manager and says, hey, we've got a mapping update. Let's make sure that all the shards, at least all the primaries are in agreement that, this mapping update, is consistent. This is actually something where, the fact that this happens, my general suggestion is if you're running a production cluster, never use dynamic mappings. Like if you've got a real like production use case, your schema is going to be pretty fixed. You shouldn't be dynamically adding fields. Like it's great if you're just setting up OpenSearch to play with it and you just want to throw some JSON at it. If you're running in production, you should probably disable dynamic mappings because this can be a major choke point. If you have a bunch of documents coming in and you don't know, well, yeah, if you've got dynamic mappings, it means you probably don't know much about the documents that are coming in. You're processing documents on behalf of someone else. And if that someone else can just arbitrarily add new fields, you create this choke point where, if there are a bunch of these field updates, this mapping updater will uh, end up pausing, or well, asynchronously pausing, the processing of your index operations, as all these mapping updates have to get propagated to the cluster manager, who updates the cluster state with the new mapping and has to propagate that back out to all the data nodes, and only then can you safely proceed. So yeah, not great. So, TLDR, yeah, if you want to have a robust production system, probably turn off dynamic mappings. So, oh, sorry, yeah, at the end here, we've just got this return true. Oh, sorry, no, yeah, that return true was if we had a mapping update required. Yeah, so yeah, the mapping update on response. Yeah, so we kind of reset this thing for retry. Yeah, I guess if there was a mapping update, then we returned true. Otherwise, we actually do this on complete, which I think should notify a listener. Let's see. So we've got the result from the engine. That's our index result, right? This is the thing that came from calling the IndexShard dot apply index operation on primary. In this on complete, yeah, I guess one thing is, yeah, we're going to want to convert this result into, well, eventually we're going to have to convert it into a bulk item response. Yeah, this context. Sorry, I'm kind of wondering, where did we update the context to set? Yeah, okay. Yeah, we haven't updated the context right? Because we didn't pass the context down into the apply operation on primary. So yeah, what do we do with because the context already has a bulk item response. I guess there must be, well, okay. Let's assume that we're not in a document update. Yeah, because this is, yeah, if we did an update operation, right, then I believe the update response, I believe this one is, yeah, this update response is the thing from going and fetching the existing document and applying the updates. And so this is where, yeah, we still ultimately need to go through and do the actual indexing. So we've got the context, we've constructed the bulk item response. Well, here, if we go to this else, okay, so the response ends up being exactly this execution result. And now we do this mark as completed. So we've got this translated response. Yeah, I guess, yeah, something that kind of puzzles me is when did we get from the index result to this bulk item response? Where did we build that? Right? So this execution result, where did this get set? Execution, okay? No, this is fail on mapping. Okay. Oh, mark operation as executed. Where did this get called? Yeah, I missed this. No, this one is in a failure. Oh, in the on-complete. Okay. Yep. Yep, I missed it. Yeah. Oh, yeah. It was right up at the top of the same on-complete method. Okay. So this thing here, this line here, 688, is ultimately what constructs this thing that we use on line 692. That's a bit confusing. Yeah. Okay. Yeah, I guess it kind of makes sense now. But yeah, okay. So now that's how we translated this result into the bulk item response. And that's where, when we translated it, this is where, yeah, we would say like, okay, well, this thing happened on the shard ID. Here were the sequence numbers. Was it a result of, did we create a new document or did we update an existing document? At some point, we should make use of do we propagate the took time? Maybe not. Yeah. So we don't actually seem to use the result took time here. I guess the took time is only used for slow logging. We don't propagate that out to the user. Yeah, that's a bit of a bummer because that's something that as a user I might kind of be interested in, like how long did it take for each thing to execute. On the other hand, it would make the response a lot bigger, so I guess I can also see some value in not propagating it. Yeah. Okay. So that's how the response was actually created. Makes a lot of sense. in this onComplete. Okay, so yeah, and then we say context.mark as completed. Finishes execution of the current request with the response that should be returned to the user. Cool. And this is in the bulk primary execution context. Let's go back to, so we were in transport shard bulk action on complete. Cool. So the on complete, sorry, who called on complete? This was in, no, here's in the on rejection. Here, oh yeah, we were in the execute bulk item request. Yeah. So we hit the end of this method. Yeah, we do the onComplete. Oh, and I guess this is where we return true. Yeah, so if there were mappings to be updated, then we return false. Otherwise, we return true. And now we go back to that loop. Cool. So, yeah, this is where we're iterating through the operations in the context, the bulk primary execution context. For each one, we're saying like execute bulk item request. If this thing returns false, that's like, whoa, okay, kind of stop everything in a way. Like, let's stop running because there are more there's a mapping update to to execute. So we're waiting for a mapping update on another thread that will invoke this action again once it's done. So we just break out. So we're saying like, okay, yeah, someone else is gonna call this again once the mapping update's done. And otherwise, yeah, let's assume there are no mapping updates. So we just iterate through. In our original example, because we were looking at just the indexing API, our context has size 1, right? So we're only doing one index operation. So we've done the execute bulk item request. It's returned true. And so it's like, yep, yay, I either succeeded or I guess potentially failed. Like I wasn't rejected, but maybe the operation might have failed for a version conflict or something, but it's still done, right? Like there's not anything we can do with it going forward. So now, yeah, we'll call finish request. And here's where we trigger the action listener. So we had our listener that, because of course all of these transport actions are asynchronous. They have some completion listener, and so we call it with the right primary result. Of course, the listener, this is the transport shard bulk action. When it was created, or technically when we called perform on primary. Yeah. So, yeah, there's this action runnable where it's got the listener, it captures the listener, and we were down in its finish request method. So this is the listener that was passed into perform on primary. So let's trace back to find that listener. So dispatched shard operations on primary. So here again, we have that listener, which, yeah, is the thing we passed into the dispatched shard operation on primary, which came from the underlying transport write action. And so, yeah, here we had a thread pool executor. So yeah, we're making use of, so the executor function, this is the thing that is deciding if, like, which executor are we which executor are we using? Are we using the basic indexing thread pool, or I believe, this was a while back that we covered this, but if this is an update to a system index, I think we use a higher priority separate thread pool to say, no, we still want updates to system indexes to go through, even if the index thread pool is busy. But anyway, yeah, so regardless of which thread pool we used, yeah, we executed this runnable where, yeah, the runnable calls the dispatch shard operation on primary. In my opinion, this shouldn't be dispatched. It should just be dispatch, right? Yeah. Yeah. Again, maybe we can clean that up. So this thing had the listener. So the thing that called shard operation on primary. So this was transport replication action, where, if I recall correctly, what was so transport write action extends transport replication action. So But yeah, transport replication action, this is covering any sort of operation that we want to happen on a primary and presumably subsequently its replicas. So here's the primary shard reference where we've got its perform. We've got the replication operation. So we say primary.perform and note that we wrap the action listener, right? So this would have already had, so this replication operation, yeah, sorry, this is because we're passing in a listener and we are wrapping the handle. Okay, yeah, so we're wrapping the handle primary result. Oh, okay, yeah, no, sorry, yeah. The handle primary result presumably will call back to the real listener. Yeah, here's the results listener. Okay, so because we were successful with our indexing, yeah, we end up calling handle primary result. Cool, so this is the success listener and this is the failure listener. And yeah, we've got the handle primary result. And now, aha, this is where we propagate, kind of from the primary to the replica, I think. So from the primary result, we get a replica request. So this is a test case, transport replication action. Yeah, probably this, I guess. Yeah, I'll be curious to look into how the replication happens. Because, so this here, we got here sort of as a result of the perform operation on primaries. Yeah, or yeah, they're somewhere, maybe in transport write action. Yeah, primary operation size, somewhere we called perform operation on primary. Maybe, we called dispatch shard operation on primary. Yeah, which was called, I think, via, they're one way or the other. Dispatch operation on primary, I think, called perform operation on primary. And we're going to get in with the transport replication, in replication operation, we're going to get down into a perform on replicas. And yeah, that gets into how does index operation replication actually happen. So, we've successfully, finished indexing this thing on a primary shard, and we're gonna, punt out to the replicas. But I think that's gonna have to wait for for next time. Sorry. So, yeah, that's it for today. Stay tuned next time when we get into how an index operation gets replicated. Thanks.